If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, I welcome you all to lecture 2 of this GATE Engineering Math Differential Equation series. So today I have taken 3 questions, question number 4, 5, 6. Some questions on linear differential equation, first order differential and a second order differential equation. So okay, then let's solve it. That is again given dy dx is equal to e to the power minus 3x is, and that is the differential equation they have given. So what you will do, this is very easy, so no need to take Laplace also. You just integrate, that will give you answer. If you take variable separable dy one side, dy is equal to, this is the simplest differential equation you can ever got. So it is y e to the power minus 3x by minus 3 plus some constant, that is k. I guess it is your option A. Okay. Next is the question number 5. What is in the question number 5? In the question number 5, with the initial condition x1 is equal to 0.5, find the differential equation solution of dt dx dt plus x is equal to t. Now here you can think of, here Laplace will be a problematic because t is there. So once t is multiplied in time domain, in Laplace it is differentiation. So if you are changing it to Laplace and then you are again using differentiation, so you are using Laplace for getting eliminated these differential terms, but for this t again one differentiation will come. If you divide it by t also, then also an integration will come, so that will make problematic. So rather you solve it by your linear normal methods. So by seeing it, if you divide it by 1, by seeing it you should remember something in your class 12 memories or even high school memories, that was dy dx plus py is equal to q. That is linear differential equation, LDE. Simplest linear differentiation, x and nothing else. You can see one differentiation of x, no d, then completely blank d. So how to solve this differential equation? For need we need integrating factor. You recall integrating factor e to the power minus p dx it was. So what is p? P is here 1 by t. So minus 1 by t dt. So if you do, it is minus 1 by t dt, then it is e to the power p dx, no minus, e to the power p dx, sorry. So it will be to the power log t, so then it is t only. So the integration factor we are getting here is t. So what is the solution for this one? You remember the solution for this one, y into if is equal to integration q into if plus c. Q into if, that is with respect to x here. So here what will be? Here your x is your y, so it will be x into if is equal to q is here 1 into if dt plus c. So here this one will be your, so if you do this one, now x into if is t and integration of t dt plus c. So it will implies xt is equal to t square plus 2 by 2 plus c. I think they have given some condition, initial condition. This is the initial condition that is given. x1 is equal to, what is this mean? This means at t equal to 1, x is equal to 0.5. So if you put t equal to 1, then x equal to 0.5. So x is equal to 0.5, if t equal to 1, if you put it, then you will get c is equal to 0. So that means what is your final answer? xt is equal to t square by 2, which implies x is equal to t by 2. So you remember your class 12 maths, it is of linear differential equation, LDE, using integrating factor. A differential equation of d square y dx square, initial conditions are given, then solution. So it is a simple differential equation. So we can take Laplace of this one here, because it is a simple second order differential equation. So if you take Laplace, it will be easy for you, because in that case your normal differential equation, if you solve here, there will be constant c1 c2, you have to put initial condition and you have to find, so that will take some time. So it will be x square x minus s into, what is the first initial condition? x0 is 1, minus what is the second initial condition differentiation of x, that is plus 0 minus 0. So it is done. Next 6 into x sx, one differentiation, minus x0, what is the initial condition? 1, plus 8x is equal to 0. So if you do x, if you take common, it will be x square plus 6x plus 8, which will be equal to, so now again you can apply this one. I have already mentioned you how to calculate a will be equal to, suppose the first one I have taken a, I am not writing it in detail, so numerator will be same a, so I have written it in this format, a by s plus 4 plus b by s plus 2. You can fill it. So if it is a, so you will remove that a, what is there in the denominator of a, s plus 4. So you will remove s plus 4, we will take only s plus 2 and we will plot s plus 4 equal to 0 here. That means equal to minus 4. So 6 minus 4, 2 divided by minus 4 plus 2 minus 2, that is minus 1. So if you again b, it will be s plus 6, numerator is same, denominator is b, denominator is s plus 2, so we will not take s plus 2, what is the other factor, s plus 4, and what we will put here, the denominator is 0, s plus 2 is equal to 0, denominator of b. So s is equal to minus 2, 6 minus 2 is 4 divided by, then 4 minus 2 is 2, so it is 2. So if you take it, so it will be minus 1 by s plus 4 and then minus 1 by s plus 4, then 2 by s plus 2. So if you take now inverse, so it will be 2 e to the power minus 2t, if I am writing this one plus minus e to the power minus 4t. So I think this is the answer, this is option B. So you can see here it becomes so easy in Laplace only in 2-3 steps, because if you know this one you can directly calculate. So for simple differential equation it's very easy and handy. It will take less time to calculate it using Laplace, because if you use normal one, then there will be, you can remember there will be cases C1, C2, C1, E2. We'll see in typical questions we have to use that one also. But in simple case where there is no t multiplication, nothing is there, it's like here t was multiplied, so the Laplace will become problematic here, like here t was multiplied, so it will be a problematic, or t is divided, whatever. So these cases will make problematic for you. Otherwise in normal cases we can take Laplace and we can solve it. Okay, then if you liked the video, then press the like button and please give your valuable comments in the comment section.